That's good. So you are welcome back to the class as we kick off with question number 13. Remember, this particular question is a continuation of question number 12. I think I'm happy with what I'm saying now. That's good. Okay, this is what the screen is meant to look like for me. That's good. That's good. So you're welcome. We already solved this question number 12 from the workbook, which was based on first principle. And we shall be moving on straight to question number 13. Like I said, today the GMAETS 41 is kicking off. Class already is on, okay? The physical class on campus in UNIZIK. So this is directly to those who are in UNIZIK, all right, Nnamdi Azikiwe University, and you wish for further learning assistance. You want to join the physical tutorial. GMAETS 41 is right there to help you. Today we'll be having a physical tutorial. So you can always contact GMAETS 41 on WhatsApp, okay? You can also call this contact so as to get further information regarding the class. But of course, for those who prefer online, remember here 247, there is no time to waste. Like I said, whether online or offline, I am right here with you, committed to giving you the best. So I am going to wipe this question. For any who had not seen this, please, you can see it there, and I'm going to wipe it so that we'll move on to the second question. All right, question 13, please. No time, okay? So we'll be fast. I want to round off so that I can prepare to also come to campus, you know, to come and speak to some of you regarding our classes in preparation for our physical tutorial today. Meanwhile, don't forget, tonight, this is question 13. Tonight, I guess we have physics 102 revision. I'll be solving chapter 2 of your workbook for those in UNIZIK. So by, I think that should be around 8:30 or 8:45 thereabout. So you can check, we have a timetable we follow for that. So this question number 13, we have this. Derivative of sum is dash of derivative, and derivative of difference is dash of derivatives. Let me write it on the board so you understand what I'm talking about. In the manual you have derivative of sum is dash of derivatives and derivative of difference is dash of derivatives. So what the examiner wants you to do is fill up these gaps, right? Now, under rules of differentiation, we have these 4 rules usually quoted, okay? Sum and difference of functions in differentiation. We have product rule, we have quotient rule, we have chain rule. Now, when I give you 2 or more functions and they are being added or subtracted, that is the case you apply sum and difference rule. So if you have sum of terms and I ask you to differentiate that function have this plus that, and I say you should differentiate, it is simply the sum of the derivative of each of them. Imagine I give you f of x to be equal to, I can say y, you know this y is the same as f of x. So let me say f of x, which is the same as y, is this function. Let's say g of x plus h of x, either plus or minus as the case might be. To get my dy dx or f prime is equal to differentiate this dg of x dx, that is differentiate this function g of x with respect to x. When you are done with that, before you move on to this guy, put this sign you have, either plus or minus, depending on the sign that the examiner gives to you in the question. If it is plus, you fix your plus. If it is minus, you fix minus. Then you differentiate the second term. d dx, which means differentiate with respect to x, what that other function is, which is h of x. So you notice that derivative of sum. Derivative of sum is simply the sum, the summation, the addition of the derivatives. These are the derivatives, this and this. So if in the question we are asked to find maybe derivative of this sum, differentiate this, that is, find the derivative of this function, find the derivative of this function, then add them together. Which means that the first space here will be sum. Derivative of sum, derivative of terms being added, is simply the sum, is simply the addition of the derivative of those terms. Whereas the derivative of difference, if this is minus, like I said, it's still the same principle. It's just for you to fix the sign. Derivative of difference is going to be the difference of the derivative, the subtraction of the derivatives. So that is it, okay? As simple as that, you have filled up the gap. Let's move on to question number 14. This is just to fill up the gap, provided for you. Question 14. Let's look at something much more, interesting. Okay, this is still a funny question. Question 14, you were given this question. If y is to be equal to x raised to the power n, find dy dx. Find dy dx. Please make sure you do not miss our class, our full class, right? Whether it is for the physical tutorial for those that prefer physical tutorial, as the case might be. But like I said, don't just prefer physical tutorial completely. Always combine your physical classes, whether lectures, whether tutorials, whether your personal physical study, right? Always combine it with online, because here online you have a unique teacher which you have selected. It could be me, GMAT 41. It could be another, right, educator that is very good and is doing this online work. Yeah. Once you have that choice, you select that person, follow up with the person. Anytime maybe there's a particular topic you want to deal with. Are you following, right? Just follow up with the person, learn one or two things. So always combine your physical learning with online. Don't joke with your online learning. Very important. Am I communicating? So all these things we are doing here, we're still joking. Right, you need to get a full understanding of differentiation. In our physical tutorials, like I said today, I'll be dealing with that. In our online class, we have video lessons that covers this already, so you can take that. Are you following, right? You can take that. You can send a message to me on WhatsApp, this contact, right? And then send your name, your level of learning, and where you are contacting us from, so that we can add you to our WhatsApp group, and then you will follow up and know, how to locate certain video lessons, because I usually guide students that are online learning, okay? I guide them through our WhatsApp group. Okay, we are moving on. The next question, we have it on the board already, and what we are asked to do is, if y is equal to x raised to the power n, find dy dx. So it's as simple as that. Under standard derivative, which is the first and most important aspect of learning that a student should kick off with whenever you are dealing with differentiation. If you are learning differentiation, please, no matter anything you learn, I am begging you, the most important thing you should give attention to are standard derivatives of different functions. Standard derivative of different functions, don't joke with it. So today in our physical class, I'll be kicking it off. Online here, we've treated that. And I've given a link to guide students today, video lessons that deals with that. So we have y to be equal to x raised to the power n, and you are telling me to find dy dx. This is a power rule function. If you want to call it polynomial, the choice is yours. It's power rule function. This n is assumed to be a number. It's actually a number, a real number. So it can be positive, it can be negative, it can be a whole number, it can be a fraction. So how do we get the dy dx of this term? The rule is use the power to multiply the base. Go to the power and subtract 1. So the power is n, is going to be n times x. N times x, n times the base, right? The base is a variable. It's a variable, it's something that contains alphabet. Then the power is a number. That is how you identify this type of function. So go to the power, which is n, and then minus 1. This is what the dy dx is going to be. So that is simply what you do according to the manual. That's what you are meant to do according to the manual. Please help me and share this link to your department WhatsApp group, to your friends, to your classmates. They need this. There are no two ways to read. Are you following, right? So Send it to them so they can connect to the class. If you are here to subscribe right away, don't waste time. You saw what happened this morning. This is the second class I am, hosting. The first one, this is a continuation of it. So if you are not a subscriber and if you have not turned on the notification bell, you won't receive a notification on this. So it's very important. That one is free of charge. Subscribing is free of charge. All right. And turning on notification bell is free of charge. So if those are free, why waste your time? Please do that right away. Then like this video, like it so that YouTube can also recommend it to as many as possible. All right, we are done with this particular question. Please finish it up as we move on to question number 15. It is as if we are playing. It's as if we are playing, right? Because all the things we've seen here under differentiation, one would assume, is this what we do in differentiation? No, that's not what we do. It's just because we have a manual we are solving. So following the questions provided. Let us look at this question number 15, right? It's not funny. It's not funny, but with GMAETS 41, it is 1 plus 1. Yeah, it is 1 plus 1 with GMAETS 41. Okay, let me see the space, what it is like, so that... T, thank you for the reminder to the students. Remember to respect your teachers. That's good. That's good. Remember to respect your teachers. Teachers have to be respected. Yes. Wherever you meet them, whether in your schools, your lecture, respect. It's not easy to teach you. It's not easy. Then respect me too. All right, let's go on, please. So this is question number 15. Let's see what your workbook says. If exponential minus 2x plus y is equal to 3xy, then find dy dx. This is good. Then find dy dx. I've been looking for realistic questions, not all these things we saw in question 12, 13, 14. This is a unique question in differentiation, okay? Find dy dx. Now, I'm going to follow the format in which, your manual presented, because you are asked to fill up some things. Spaces were provided, boxes were provided for you to fill up. So I'm going to follow that pattern. However, you need to know actually how to solve this kind of question. First, this question is an implicit function. And then somebody might ask, what is implicit function? Right away, I might not be able to talk much about it because we are just solving questions here. Just solving questions, okay? This is not like a full teaching of the topic. If you are an online member, become a channel member on platinum level at least. That is 2,000 naira per month. Are you following, right? Then for full learning, in order to get full attention of GMAETS 41, both online and offline, if you want to join us online, do your full registration that covers that online something, okay? Yeah. So you can learn the basis of all this. In our physical tutorial, of course, those are fully registered members also. They are going to get a detailed explanation of this stuff. For implicit function, how do you identify it? It's just a simple thing. Number one, the dependent variable, which generally is y, will exist more than once in that function. It will exist more than what? Once in that function. And if maybe it appears only once, for example, the power of that dependent variable, which is y, the power will not be 1. The power will not be 1. So these are the two conditions for identifying implicit function. And the way you differentiate implicit function is unique. It's unique. It's unique. Take note of that. So become a channel member. You can register for our online classes. You can register for our physical tutorial. The physical tutorial also gives you automatic entry into our online classes as well too. And all this, you will learn the full details. So in the manual, you were given this. dx, open bracket, minus 2x plus y, close your bracket, exponential minus 2x plus y equal to, have equal to here actually, but no space, so I come down here, equal to, what is the meaning of this as presented in your manual? All these dy, dx, I had already said that In differentiation, this thing stands alone as an operator. It is just like the way you have times, divide, plus, minus. Once you see something like times, there must be two numbers or terms that you would have the times between. So the multiplication, the times is operating on those two numbers. Once you see times, it means you have this term and you are multiplying it by the other term. That is what this operator is in differentiation. Please, anytime you see all this dy dx, hey, this y is separate. This y is separate. This y is a function. That is what this operator is operating on. That is what this operator is working on. D dx is operating on y. This is telling you differentiate with respect to x anything that y is, anything that the function is. The function now is what you have here, right? And how do you obtain it as you have it there? So all you have to do is to differentiate. Differentiate that function. Do you understand that? So this is an operator. It works on whatever has been given to you. So in the manual, your examiner quickly wrote, d dx of all this time. I know you are there, might be wondering, how did this come about? How did this come about? Right? Of course, this guy you're seeing here is as a result of maybe derivative of this term on top. I actually fault this. I fault this thing I have here per se, because it's much like, okay, you are differentiating this term with respect to something, but it was not quoted what you are differentiating with respect to. Okay, so this was what was given. After this was written, which I must be honest, like I said, there is no basis for this term generally. I don't say there is no basis generally for this term, but all the same, it was made equal to this. It was made equal to 3xy prime, then plus, it was made equal to 3xy prime plus, you are now asked to fill up something here. A space was provided for you to fill up something. Now let me show you. This 3xy prime means 3x dy dx. The truth of the matter is I don't like this thing that was done in your manual. Yeah, I don't like this particular question. There's a better way of solving this. Yeah, there's a better way of solving this. The onmakers del f del x, that's minus del f del x all over del f del y solves this question in just one step. Yeah, I know that from what I'm seeing here, they try to use the general method of solving this, which in our class, I've solved all of this in the online class. In the physical class, I'm going to be dealing with that as we start differentiation today. How this came about. You'll be told anytime you differentiate y, multiply by dy dx. Okay, that's good, but that is not good to do in exam. Don't worry, all of this, you have them dealt with on this platform already. So let's move on exactly to what we have in your workbook. So look at this term. This is what they were trying to differentiate. This is what they were trying to differentiate. Are you getting me right? Yeah. They differentiated this part with respect to, let's say, x. So even this minus 2x plus y that I have here, I don't really know. I think it's supposed to be d dx of this term alone. D dx of this term alone. This bracket is not supposed to be there. That's what I'm trying to say. But in the manual, the bracket was provided. I feel it could be typographical error in a way. Yeah, that's what I feel. It could be typographical error in a way. Because for you to differentiate this term, I could have thought that this is meant to be d dx of the left-hand side equal to you differentiate the right-hand side. Remember, we are meant to fill up something, but I'm trying to explain why I fault this first line in your manual. That thing doesn't make sense. In fact, it's wrong. It's a mistake. Yeah, it's a mistake. It could be from maybe the typing process. So if you tell me differentiate this, if I differentiate this with respect to x, what I'm going to get will be minus 2 exponential minus 2x plus y. The Omak's major minor differentiation simplifies this, which is a classical interpretation of chain rule. The idea is simple. You have an exponential function to differentiate. Now what you do is differentiate the minor function with respect to x and then differentiate the major function. If I differentiate this term with respect to x, I'm going to get minus 2 because this x, if you differentiate, you get 1. 1 times minus 2 will give you minus 2. Differentiate this 1 y with respect to x, it will be 0. It will disappear. So you are left with just -2. Now, the derivative of the minor function, this whole term, with respect to x, which gives us -2, use it to multiply the derivative of the major. The major is exponential. If you differentiate exponential directly, that function, you will get exactly the same thing that was given. You'll get that same exponential, -2x plus y. So when this was written, there was no reason for this. There was no reason for this. Yeah, if you must put ddx, you could have just written this exponential term. Then maybe below, we'll now write the result of what the derivative of that exponential term is going to be. But all the same, like I said, let's just follow the pattern, and I'm going to write down what the result is. Having said that, this term given to you, it was written in the manual, 3xy prime, meaning 3x dy dx. That is derivative of this part with respect to x. Derivative of this part with respect to x. And if you are, oh no, sorry. Yes, with respect to x, because in the general method, you differentiate everything with respect to x. So here, if you are differentiating this term, you are meant to use product through. You are meant to use what? Product through, because two variables are being multiplied there. How do you work on that? You are going to have 3x. Keep 3x constant and then differentiate y. If you differentiate y with respect to x, you are going to get 1. Since you are differentiating this y with respect to x, let me ask, if you are differentiating y alone, a term alone, I give you any alphabet in its simplest form, in its basic form as you see it in ABCD. If you differentiate it alone with respect to itself, you get 1. With respect to itself, you get what? 1. So normally, if you differentiate this y as it is with respect to itself, you are meant to get 1. But in this general method, you are differentiating everything with respect to x. So since the derivative of y alone should give you 1, but you are differentiating with respect to x, you must multiply whatever you get with dy dx. Let me assume that that term is maybe 3xy squared now, for example. If you keep 3x constant, differentiate the y squared, you will get 2y. Then since you are differentiating y squared with respect to x, you get that 2y, multiply that result by dy dx. That dy dx is your y prime there. What is the implication of multiplying that term with respect with dy dx? It is to tell somebody that this derivative is done with respect to x. Anyway, like I said, we're going to meet all these concepts in our full class, okay? We're going to meet in our full class. I'll still take this concept online. Yeah, just a part of this implicit function. But the video lesson is already there on our playlist, and our members have access to it. Become a channel member to get access to all of these key lecture videos. So we move. I have shown you how we got this 3x y prime. It's simple. They kept this 3x constant and then differentiated y. If you differentiate y, you will get 1 multiplied by dy dx, since you are differentiating with respect to x. Then next, keep 3y constant. Keep 3y, this 3x constant, and then differentiate with respect to x. If you do that derivative with respect to x, you are going to get 3x. You are going to get what? 3y rather. 3y. Remember, the first, you kept 3x constant, differentiated y. The next, you're going to get 3y constant and differentiate what? X. That is the concept of product rule. So this particular term, space was provided for you to fill it up. Yes, space was provided for you to fill it up. So that is it. So you are differentiating this whole term. Okay, they went ahead and wrote ddx of this term. How they brought these brackets, there's a mistake there. I've said that. Equal to, then differentiate this term with respect to x. You are using product through here because this x and y, they are being multiplied. So move on, differentiate, keep 3x constant, and then differentiate y with respect to x. You get y prime, dy dx. Then plus, because in product through you have plus. Next, keep 3y constant. If you keep 3y constant, differentiate x with respect to x. If you differentiate x with respect to x, you get 1. 1 times the 3y will give you 3y. So that term there is filled. And then next, in the next line, you were given dy dx to be equal to, dy dx to be equal to, in fact, this whole space was left for you to fill. This whole space was left for you to fill. So what will the dy dx be equal to? Like I said in the general method, there are so many things that were not presented in that manual. Yeah. Let me not say so many things as if there are extremely many, but there are key simplifications that were not provided. And because the manual didn't provide a space for us to do that key simplification, I won't provide it. I'll just write the last thing because this is the last line we have there, where the result is now going to be 2 exponential minus 2x plus y, and then plus 3y all over exponential minus 2x plus y, and then minus 3y. That is the result. So you are meant to feel this. I know that many of us might not even understand why this is the result. But if I decide to be very, very fast, can I achieve your getting to see this and getting the idea a bit? Let me wipe these parts so that I'll be very fast in showing you what was done here, okay? I will show you using the general method. But with respect to your exam, I do not use the general method to teach implicit function. I don't. I have the omega del F formula that I use to deal with this, okay? So look at the question given to you was exponential 2x plus y equal to 3xy. Because what was done in that manual, let me not say it doesn't really, this particular question, it doesn't really follow well. It doesn't. So differentiate this whole term with respect to x. I'm using the general method. And the general method, I don't like it. That's the truth. I don't like it. There are some kind of functions given to you to become very terrible to be able to solve it. Like this one now. And many other ones. The general method is only convenient for me. For me, it's only convenient to use if you see problems where all the terms they are polynomial. Once it moves away from polynomial, it becomes a bit challenging. And even in that polynomial, if you have combination of terms that are being multiplied or divided, where you expect to use either product or quotient, it becomes a bit tough using the general method. But don't worry, the omega del F formula deals with it in just one step. So we are differentiating this with respect to x. So what will I do? Do your major minor derivative. I'll differentiate the minor. If you differentiate this term with respect to x, you get minus 2. Like I said earlier, you get minus 2. Differentiate this y with respect to x, you will get, the concept of 0, because of course you can't get that. You get 0. So derivative of this with respect to x will give us minus 2, then exponential. You're differentiating the minor function, you will get this minus 2x plus y plus y. I think there is a term that I am meant to put here. Differentiating this with respect to x, all the terms. Okay. So this is what you're going to get. Come here, differentiate this with respect to x. You get minus 2. Then plus differentiate this with respect to x. You get dy dx, which is your y prime. Yeah, I think this is the term that actually is meant to be here. This term I have here is the derivative of this minor function with respect to x, then multiplied by the derivative of the exponential term, which will still give you the same thing. Equal to, come here, apply your product rule, keep x constant, differentiate this y, which will give you y prime. I just showed you. That y prime is the same as dy dx, and then plus, keep 3y constant, and then differentiate x. If you differentiate x, you get 1, so times 1, no need of putting it. You get 1. All right. So at this point, you are expected to put all the y dx on one side, like simplify that to get only one dy dx there. To achieve that, I have to open up this bracket. This is going to be minus 2 exponential minus 2x plus y, and then plus this dy dx will multiply this, which is dy dx times exponential minus 2x plus y. That's going to be equal to 3x dy dx and then plus 3y. I hope this does not cut off. If it cuts off, manage it. My ink has spilled. I'm spending a little time on this question just for you to get 1 or 2 ideas of it. Collect all the dy dx together. You are going to get dy dx exponential dy dx exponential minus 2x plus y this time. Then this will move which is minus 3x dy dx, and then minus 3x dy dx. Then we have this term plus 3y equal to 3y will be on the right hand side. This whole term will move. If that term moves, you are going to get, think I've got to correct something here. This denominator is meant to be 3x. This denominator is meant to be 3x here in this result. So collecting all dy dx together and then moving anything that does not have dy dx to the right hand side, this term will move. So you have plus 2 exponential minus 2x plus y. All right. So factorize the dy dx term here. If you factorize the dy dx, in brackets, you'll be left with exponential minus 2x plus y, then minus 3x, and that's going to be equal to, come to this term, and then I'm going to have 3y plus 2 exponential minus 2x plus y. Making dy dx subject of the formula, it is going to be 3y plus 2 exponential minus 2x plus y, divide every time by this coefficient of dy dx, which is exponential minus 2x plus y, then minus 3x. So that is the solution, and you can see that here. 2 exponential minus 2x plus y, look at it, 2 exponential minus 2x plus y is positive. Then plus 3y, this is positive, so the whole numerator is positive. Then the denominator exponential minus 2x plus y minus 3x. Exponential minus 2x plus y minus 3x. So that's the general approach, the general method you can use in solving this question. That's actually what, if the detailed step here to be shown here. Like I said, I don't like this. There is a better way of solving this particular problem. And the better way is as simple as, if I move this term here, then dy dx is simply move this term here, so it becomes minus 3xy. So you come to this and differentiate this term with respect to x, put in negative there, minus open bracket. If I differentiate this with respect to x, what is it going to give to me? To give me minus 2 exponential minus 2x plus y. That space is not enough. I'm going to wipe this. It's not meant for you to copy generally yet. Just trying to see how at least you get 1 or 2 knowledge from this particular question. So like I said, in this term, you have exponential 2x plus y. Move this term there, have 3xy. So this becomes the function given to you, function of x and y. It depends on x and y. Okay, and remember we are solving up to question number 15. That's why this seems to be the last question I'm taking my time on. So dy dx is now simply equal to, directly, it gives you dy dx straight. Differentiate this term with respect to x first. The numerator you fix negative. If I'm differentiating this with respect to x, differentiate the numerator, is a numerator, this power term with respect to x, you will get minus 2. Differentiate this with respect to x, you get 0, it goes off. Then differentiate the major function exponential, you still get that exponential. So this is what you're going to get as derivative of this particular term. Come here and differentiate this with respect to x. If you're differentiating this with respect to x, y is taken as a pure constant anytime you're differentiating with respect to x. Because if you're solving this for the numerator, you differentiate with respect to x, the denominator you differentiate with respect to y. That is the Omega del F formula I'm talking about. So coming here, this is minus. Differentiate this with respect to x, which means you are keeping y constant. You are keeping y constant. 3y will be kept constant. Differentiate this x alone, you are going to get 3y. You are going to get 3y. Then all over, repeat this. This time around, differentiate this same function with respect to y. For the numerator, you differentiate with respect to x. So if I'm differentiating for the denominator term with respect to y, come back and repeat the same thing. Differentiate this minor with respect to y. There is no y here, so you get 0. Differentiate this, you get 1. Y with respect to y, we give you 1. So you have that 1, if you want to write it, times derivative of the major function, which is the exponential term. Differentiate an exponential term as you have it, you get that same thing. So you have this same exponential minus 2x plus y. So I am done differentiating this guy with respect to y. This one, no need, because 1 times any time is that time. Then move on, minus, differentiate this with respect to y, which means 3x to be kept constant. If you differentiate this y with respect to y, you will get 1. 1 times 3x will give you 3x. So this is the result. You have solved it. Open up the bracket with this minus. This will become positive. 2 exponential minus 2x plus y. Use this minus to multiply this minus. You get plus 3y all over. Copy the denominator exactly as you have it. I know that most of you will be like, wow, this method makes sense. Why are we doing all of this when we could just do this simple thing? Your first step alone gives you the answer. The Omakers del F formula. Generally, in your lecture hall, you'll be taught this method generally, okay? Maybe in one way or the other, anybody might choose to. Anyone that knows about the Omakers del F formula, because I've been using it for years. Yeah, after publishing it, I've been using it for years. If you see this method, good enough. But my students, I usually use this method to teach them in preparation for the exam, the del F formula. But I still do this for them to get a little idea of what that method or implicit function is all about. All right, guys. So you see in both cases, we had the same answer. Look at this. Look at this. They are the same thing. And that is the result we said you're meant to get in your manual as so required. All right, guys. I think we have spent some quality time on this. Like I scheduled, this question we're meant to cover questions 12 to 15 in the manual, which we have done that already from question 16, 17, 18, 19, 20, 21, 22, 23, and 24. They are also from calculus. They are from calculus, but I think question 18, 19, and 20 is from integration. It's from integration a bit. Let me adjust the camera so that every part of the board will be captured. I think the thing cut off a bit. All right, good. So we shall be meeting next, okay? Next time we shall be meeting in our next maths class. I think that's going to be tomorrow, because tomorrow online I'm meant to take you math 102. That's a general online timetable. Our specific online timetable follows our physical tutorial timetable. Like today, we have math 102. Yeah. And then the online, the links to the lecture videos we're going to cover, the links have been dropped in our WhatsApp group for our dear online students to have access to read. All right, so make sure you become a member of GMAT 41, like I always advise. You can join us online. You can join us in our physical tutorial. Register for any one of them that is convenient for you. Okay? For those in different parts of the world and others, you can join GMAT 41 on platinum or on diamond level. Do you get that right? Okay, so I'll be seeing you later tonight by God's grace, where I'll be dealing with physics 102. We are going to be solving chapter 2 of UNIZIK Physics 102 manual. That chapter 2 actually is drawn from current electricity. In a previous class, in Physics 102, I treated chapter 1, drawn from electrostatics. So make sure you stay tuned. Like I said, if you have not subscribed, please do yourself good. And also, of course, I'll appreciate your subscription. That's so wonderful and appreciated. Subscribe, hit the subscription icon, then turn on the notification bell. These processes are free of charge. No dime is removed from you. The reason for this is anytime I upload any content, almost every day, things appear on this channel. And we have class almost every day, right? Good, because this is an online stuff. So wherever you are, it's convenient. You can join the class from anywhere, anytime. When the class is done, if our live classes are over, a copy of the lecture will be made available. It will be there, so you can still come back. So if you subscribe and turn on your notification bell whenever I am hosting a live class or I upload any content, a pre-recorded video, YouTube will just send you a notification and tell you GMAETS 41 has dropped something. So you check by, it could be something you need, and then you take the lesson. No time to waste, okay? Please utilize your time very well. Then I will appreciate the most. You can go further to support this channel. Become a channel member. You can join our platinum level or diamond level. The higher you join, the more benefits you get. Like the diamond level would give you full access to my personal services when necessary. Are you getting me? Yeah. You can ask questions offline if you're on diamond level. If you're on platinum level, there are so many benefits you also get to, right? So that is okay. Like for me, I advise from platinum level and above. Don't go for gold level, please. Because the gold level won't give you anything much. Yeah, it won't. Right? Please support us from platinum level and above. The platinum level gives you access to all the lecture videos on this channel. All the lecture videos on this channel. But certain personal services, it might restrict you from it. All right, guys, we shall meet later in the evening. For those in UNIZIK, I'll be seeing you today when we have our physical tutorial Math 102. I'll be kicking off differentiation. Yeah, because that is the topic we're entering today from scratch. Don't miss the class, please. Do have a wonderful time. Zainab Bangura, you are new here. You are welcome. Please, if you are new, subscribe immediately. Turn on the notification bell. We have just concluded this particular class, okay? And then on your own, you can go through our playlist, GMAETS 41's playlist. Please go and check it out. Go and check it out. You'll be amazed by things you would see there. So you always come back, all right? We'll have class later this evening, physics, on electricity. So you can connect in the evening, there about 8:30 or 8:45, I guess so.